Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Okay, this is an interesting problem we have here. So this is the setup that we're given. We have a wire that starts here, point A, goes to point B, goes to point C, and then goes up to point D. This is a three-dimensional grid. We're also given the magnetic field that points in the positive Z direction. So it's in the same direction as this segment C to D. And that points perpendicular to the plane created by the x-axis and the y-axis here. The z points up from that axis. You can think of x and y as your paper, and then z points straight up out of the page. This is three-dimensional. So now what we want to find is the force on each segment. Alright, right off the bat, we can rule out the force from the segment from C to D here, because it's in the same direction as B. And we have an equation here for force. The magnetic force is equal to the current times the length that the current's flowing through, in this case the wire, times the magnetic field present. Now the important part is this is sine of theta. When the magnetic field is in the same direction as the current, the traveling current, we have sine of zeta, sine of theta is equal to 0, or we'll have theta is 0 and sine of 0 is 0. So for the line from C to D, we have no angle difference. They are in the same direction or parallel, which means that theta is equal to 0. So we don't have to worry about that case. We can write it right here just so we don't forget. Actually, this is C to D. We have the segment from C to D is equal to 0, the force. 0 newtons. Okay, ruled that out. So now we need A to B and B to C. So we'll need to do a force equation for each one of those segments. Now we are given the magnetic field through the whole thing. We are given the lengths for each wire. And we are given the current. Now this current, these are all connected, which means that the current will be the same for each segment. So we'll need the length from A to B for the first part. And you'll need the length for B to C for the second part. And then of course C to D is 0. So you simply plug in the length for L, B and I stay the same. Now what about the sine of theta? What direction do we have between B and I? So we have B points in the Z direction, and both of these two lines travel in the plane of X and Y, which means that if we take this segment, we're going to shrink Z down so that it's in the same plane as X and Y. So we have the sides of a rectangle here. You could complete the rectangle, maybe to help you see. So this is closed in this area. Now the z-axis points up out of that. And between these two planes is a right angle, which means that the sine of theta, or this theta, in this case, is 90 degrees. They are 90 degrees or orthogonal to each other. So for both cases, because it points straight up for C to B and A to B, because they're both in this rectangle plane here, which we have sine of 90 degrees is 1. So all you have to do is change L for A to B and B to C. So you'll have one equation. You'll write your force here. For the first one, A to B. Oops, we forgot the B. A to B. That's the force from A to B along that wire, times ILB. Current is the same in all cases. The L will change. You'll have to enter the L for that segment, times the magnetic field, which is also the same. And then you'll need another one to find the force on B to C. From B to C. Same thing is equal to ILB because sine of theta is 1, because it's still 90 degrees. The only thing that'll change in this case is the L, the length of the wire. And there you have it. That would be how you calculate your two forces here. Only thing that changes is the L, the length of the wire.